In this video, we're going to look at how you can use the RAFE platform to seamlessly migrate a workload from cloud to edge and from the edge to cloud. We'll first start off with the use case where an application can be migrated from cloud to an edge environment in just a couple of clicks. And then for scenarios where it is more pertinent to move an application from an edge to the cloud. For example, if you're decommissioning an edge, how do you migrate the application to the cloud, either temporarily or permanently? Let's look at how the RAFE Kubernetes operations platform helps you achieve that easily and quickly. We have two clusters. The first cluster is running in the cloud. It's running on Amazon EKS, is running in the Oregon region, US West 2. The other cluster is running closer to the users in the edge. This is running in San Jose, which is closer to where the user sits. Now we're going to start off with the first use case where we're going to deploy the application in the cloud, and then we're going to migrate it to the edge. And then we'll go the other way around. So let's first start by publishing a namespace on these two clusters so that we can deploy our applications when we want to. So we're going to publish a namespace called Tom for our application called Tom. And we're going to deploy it to both our clusters. The first one is in the cloud. The second one is running on the edge. Let's go publish that. And in a couple of seconds, the namespaces will become operational on both clusters. Both the edge, which is running behind a firewall, as well as the Amazon EKS cluster running behind a security group behind a firewall. Okay, now our namespace is published on both clusters. Let's go look at it. If you go look at this particular cluster, let's kubectl in, and let's look for a namespace called Tom. And as you can see, it was just created about 18 seconds ago. Let's do the same with this other cluster and look for the namespace called Tom. And as you can see here, this was also created a few seconds ago. Now let's go ahead and deploy our application. So we're going to have an application called Tom, and this application is a generic YAML file. It could be a Helm chart as well. We're going to pull it from a configured Git repository, and we're going to deploy it in our newly created namespace called Tom. This is going to come from the main revision branch, and the particular YAML file is this thing called echo. Now let's first start by deploying it in the cloud, right? And let's go ahead and publish it. Now what's happening here behind the scenes is the controller is going to go pick up the manifests from the Git repo and deploy it on the specified cluster. In our case, it's the cluster in the cloud called demo EKS. Let's go look at that. And as you can see here, it's successfully pulled the images and is deployed all the replicas associated with the YAML file. And we have 4 of them here. Now, this cluster is running in a cluster that is in the cloud. And if for whatever reason, if the customers decided that they need to move that to an edge location, all they have to do is add the edge to it. You can optionally disable it right now, or you can have both running at the same time, and then after this comes up here, remove it. Let's go do that. The usual best practice is deploy it on both first and then turn off the second one. Let's do it in a 2-step process. So let's add the second cluster. The QA cluster here is our edge cluster, and let's go deploy it and we'll republish it. And if you notice here, the controller will determine that this has to go to both clusters, and the workload is now being sent to both clusters, and it'll be available on both. And the minute it comes up and the reconciliation is complete, we'll go check for the resources. Okay, it's done. So we already had the workload running on the demo EKS. This was a new cluster we picked. So let's go look at that. And as you can see here, in our QA cluster, we have the same echo workload running. And if I go flip to the EKS cluster, and you can see the same application working. So the same workload is now deployed to both clusters. And now, since the workload is deployed to both clusters, now we can go ahead and turn that off in our cloud cluster and republish. And now the controller will determine that it can deprovision the application on the workload on the cloud cluster, and as you can see, it left the workload on the QA cluster behind. So now let's go see whether it's still available on our other cluster. So we're gonna, and as you can see here, it's terminating, and once all the pods are gone, they'll be gone from the cluster. So in a nutshell, what we've achieved here is we started out with the deployment of the workload on an EKS cluster, and in just a couple of clicks, we were able to seamlessly deploy it on both clusters and then turn it off on the cloud cluster. And the same thing can be done in the reverse manner. If you want to move it from the edge to the cloud because you're decommissioning an edge, or you have some temporal issues with the edge cluster, you can do the same. So now we're going to try and go the other way back, and just going to go back to the workload, select the placement, add the cloud cluster into it, and publish the workload. And now you can see it's picked up both, and it's deployed on the EKS cluster too, and it's just started the containers, and we have 4 back. And now we can go turn off the deployment of the workload on the edge cluster and republish it, and it'll go turn off the workload on the edge cluster. And now we are back to the cluster, the workload in the cloud cluster. So we just saw how easy it is with this platform to deploy and operate a workload and migrate it from cloud to edge or edge to cloud in just a couple of clicks. Thank you.